Earlier this year, a relatively unknown Chinese AI startup named DeepSeek released a chatbot called R1. It drew massive attention because it rivaled the performance of models built by the wealthiest tech companies on Earth, running on a fraction of the computing power and cost. The financial reaction was immediate and brutal. NVIDIA, the primary supplier of the chips powering these massive AI systems, lost more stock value in a single day than any company in history. Accusations quickly circulated through Western media that DeepSeek had extracted data from OpenAI's proprietary R1 model without permission. The mechanism at the center of these allegations is distillation. It has been a cornerstone of computer science for a decade, used by nearly every major tech firm to optimize their own internal systems. To see why this tool matters, we have to look at a major bottleneck in AI development. Feeding neural networks more training data makes them more capable, but it also makes them bloated, expensive, and incredibly difficult to run. Rather than relying entirely on massive hardware, developers use a mathematical breakthrough from 2015 to shrink these digital brains without destroying their intelligence. In 2015, researchers at Google, including Geoffrey Hinton and Oriol Vignals, faced a logistical nightmare. To improve performance, they were gluing many parallel models together into ensembles. The outputs were highly accurate, but running all those models at once was remarkably expensive. They wanted to take the combined intelligence of those massive parallel systems and compress it into a single, efficient network. This diagram reveals a blind spot in early machine learning. Evaluating a dog image, the network outputs identical error signals for fox or pizza. Logically, a fox shares visual traits with a dog, a pizza shares none. Penalizing both equally robbed the system of context. Recognizing these varying degrees of accuracy provided the exact mathematical foundation needed to transfer knowledge between models. This probability matrix reveals how a massive teacher model assigns value. Rather than outputting a firm this or that answer, it generates soft targets, calculating a 30% chance of a dog, 20% for a cat, 5% for a cow, and 0.5% for a car. Hinton called this spread of probabilities dark knowledge. It quantifies the relative similarities between categories, linking dogs to cats and cows while mathematically isolating them from cars. The actual distillation process happens when researchers feed this complex probability web from the massive teacher model directly into a smaller student network, which then maps out those exact same spatial relationships. The student model avoids rote memorization of the correct answers. Instead, it internalizes the teacher model's nuanced process of logic and categorization. The resulting student model is incredibly lean. It requires far less computing power to run while retaining almost all the accuracy of the heavy, expensive original. Distillation proves that scaling up the physical size of a computer is not the only way to scale up its intelligence. As training datasets exploded in size over the following years, this technique became essential. In 2018, Google released a massive language model called BERT to parse web searches. The next year, developers distilled a smaller version, DistillBERT, which quickly became a standard tool in business and research. Today, major corporations like Amazon, Google, and OpenAI offer knowledge distillation as a routine service for developers. The process has also evolved into what researchers call a Socratic approach. A student model can learn simply by prompting a closed-source teacher model with questions and using the detailed answers to build its own structural logic. By studying the reasoning of a teacher model's outputs, smaller teams can approximate the performance of high-end models without the initial multi-billion-dollar hardware investment. Efficiency is the primary driver here. In January, Berkeley's Nova Sky Lab used distillation to train a highly capable reasoning model for less than $450. The evolution of these compression techniques ensures that advanced AI remains lean and accessible, moving the industry beyond a pure reliance on massive computational scale.